Good afternoon. This is the last day that I teach you, at least in this semester, and here are the topics for the final exam. Okay? So you focus on these topics, study as much as you can in depth on these topics. If it's not mentioned here, I can say that it's not on your final exam. So, all right. That being said, also remember that topics in physics are interconnected. So, but mainly focus on these. We start from a first chapter where we talked about, I'm talking about the essays first. Okay, this is one of your essays, connected systems. Now, what do I mean by connected systems? One type of a connected system could be where you have pulley, a mass here, maybe a bigger mass here, and that's the ground. So you have two masses, one big, the other small. And if let go, you know that this mass is going to go down and this mass is going to go up. And I think we did this the other day, didn't we? We did this, so did we do this the other day? Yeah, we did. No? Okay. All right. So you got to draw free body diagrams for the first object. The weight, mg, is acting down. Tension in the string is acting up. That is for the first object. For the lighter object, same thing. Mg, little mg, down. Tension up. Supposed to be vertical and all that, but then you have to remember that the heavier object is going down. So the net force must be down, right, for the heavier object, which means that mg must be greater than ft. So according to Newton's second law, the net force, mg minus ft, is equal to m times a. But when you come to the lighter object, it's moving up, therefore the upward force must be bigger than the downward one. And so again, the net force is equal to m times a. Once you get those two equations, the physics part is over. If you add those two equations, you cancel out ft, wouldn't it? Mm-hmm. And then you would get caps mg minus mg is equal to a times caps m plus m. And if you're asked to find again on the left side, you could have taken g out. So, and if you rearrange, that simple formula will give you the acceleration of the system. And then if you have to find the tension, of course, you can take the value of acceleration and substitute it into one of those equations and you will get the tension. I'm not going to write that because that's just math there. So that is one type of a connected system. So this is a second type of connected system with one moving horizontally, the other moving vertically. And let's assume first that there is no friction. Okay, so the little mass is moving over a frictionless surface. If there is no friction, then when you draw the free body diagrams, I think you can understand that nothing changed about the bigger mass, right? Mg acting down and tension acting up. Is that the case? Yeah. No change there. And since it's moving down, of course, mg minus ft is equal to its mass times acceleration, no change again. But when you come to the smaller mass and you see that its weight is acting down, there is a normal force here. You don't call it tension, right? Mm-hmm. The reaction on a surface is called a normal force. So now you would see mg and Fn, and then you would also see the tension in the string. So that means that's Ft. And one look at this, you understand the smaller mass is not moving along the y-axis, is it? No. That means Fn should be equal to mg, which we do not need in this case. correct? We don't need in this case.
So since it's stationary, like up and down wise, you can say that they're balanced.
They're balanced. So we don't need the vertical forces here. Its net force is 0. So the only force that makes it move is actually Ft. Isn't it? Therefore, Ft should be equal to m times A. Ft is m times A, and when you add those two, you surely get the formula for the acceleration as mg, in this case, by caps n plus little a. And once again, if you take that acceleration, substitute into second equation, gives you the tension directly. So that will be that case. Now, if there is friction, so that's without friction. So be careful, just write without friction there, or with no friction. But if there is friction, then what's going to happen is you have to remember the formula for friction. And friction is mu. Okay, there is mu s and there is mu k. Static friction and kinetic friction. In this case, it's already moving, so it's kinetic friction. You're asked to find the acceleration. So kinetic friction, Fn. Now that's where what I told you becomes useful. Because you remember that I told you Fn is mg? For the little mass, because friction acts on the smaller mass, right? So that's where you have to remember that, and then say, okay, friction is mu k times little mg. And then you got to go to the free body diagram and add that force now. See what I did? I added the friction, and friction is always opposite to the motion. So now you have to be watching. Did you see the new force come up on the free body diagram? Yeah, because I don't want to draw that again all the way. So therefore, now the equation changes. The first one is, of course, the same. Now the equation for the second one, what's the net force? What's the net force on the smaller mass?
Force of tension minus the force of friction.
Correct, which is mu k mg becomes equal to its mass times the acceleration. And then after that, it's the same thing. It's just the math, you can solve it. But is that clear? So obviously you'll be given mu k. If you're given mu k, you got that and then set it. So that is a second scenario. So if I did this, you see that the little mass is now moving on an inclined surface. And you could have friction or you could do without friction, depending on the question. So let's assume that there is friction. So that's not a complicated case, but you have to treat each one individually. Draw the free body diagram for the bigger mass. Does that change in any way? Huh? The bigger mass, does the free body diagram change? Nothing. So it's the same thing. So the equation for that doesn't change. It's just mg. How? Here there is another thing. Couldn't this go backwards? Depending on the slope and the masses, it could. And at this point, you do not know, so don't worry about it. But if you get the acceleration as negative, that's what it means. The sign changes, so be careful on that. So mg minus ft, assuming that it's still going down, mg minus ft is equal to ma, did not change. Now, what about the little mass? What does the free body diagram look like? I'm going to draw it right there. This is very important. What is that? That's the mass. And then the other force would be the normal force. And then if there is friction, what direction would it be in? And this is going up the plane, so friction should be down the plane. Something like that. I'm just drawing it a little off so you can see it. So that's and something I forgot. Tension. I'm drawing that also a little off. It's not like that, so you can see it. Right. Could be made. You could still see it, can't you? Yeah. So Ft. So now what is the net force? Along the x-axis. Along the x-axis. Remember, we have our x-axis like that along the plane and the y perpendicular to it.
So would it be Ft minus friction?
Exactly. And Ft minus friction is equal to m times a. Right?
Mm-hmm.
Okay. And what is friction?
Mu K.
No.
you have
No. Now that changes. So it's mu k times Fn. That's correct.
You
But
need to know what theta is.
Fn you can see is not equal to mg, is it? No. So you have to resolve mg into its two components there. Break it into its two components. That's what you do. So you have that. Maybe a little change of color. And you have that. Hopefully you can see that. And then you have to know that if this angle is theta, this is also theta. And therefore this would be mg cosine theta. And this would be mg sine theta. Therefore, what is Fn equal to? Fn is equal to mg cosine theta. Can't you see that? Fn is equal to mg cosine theta. So friction would be mu k mg cosine theta. So you take that, plug it into this. I'm trying not to write again. Because you got friction, right? Put it into that and then solve it like before. I mean, add the equations. Wouldn't Ft get cancelled again if you add?
Yep.
Yeah. So after that, there is no change. You get the acceleration, put that back into one of the equations, you get tension. So that's the only difference there. Okay, so going back, there is also mg sine theta. Therefore, the net force for the second, the smaller mass actually changes to Ft, come on, help me out, minus friction, minus mg sine theta is equal to m times a. Are you all with me? Because there's also mg sine theta that I forgot about. Not while I taught you, but today. Static equilibrium is the lab that you did, the meter stick. You tried to find the mass of the meter stick and all that. And then a special case where you have two supports, remember? If you have two supports, like one support here, another somewhere here, and then you have different masses at different points, like a bridge, and there are like cars at different points or something like that. I'm not going to give numbers. I just want to tell you if that's F1, F2, F3, and then you know that there will be reactions at the supports, wouldn't there be?
Mm-hmm.
So what are the two conditions for equilibrium?
Force has to be equal to 0.
Yep,
And the
net force is 0 and net torque is 0, right? So when you say the net force is 0, and if we call this F4 and F5, then we're trying to say that F4 plus F5 is equal to F1 plus F2 plus F3. That's what, isn't that what we're saying? Net force is 0. Total up is equal to total down. And then we come to applying the second condition. When you try to apply the second condition, it's always good to calculate the torque about one end. Except in this case. Because if you do that in this case, you'll be left with two unknowns. What's this? If you calculate it about one support, you automatically eliminate the torque due to force F4. Because if you decide to calculate the torque about that pillar, what is the torque due to F4? What is the perpendicular distance between F4 and that
The
point?
radius is 0.
Correct. The radius or the distance is 0. So that way you got rid of one unknown. So be careful on that. So if that's the point where you're calculating the torque, then this is clockwise. This is clockwise. Are you with me? This is counterclockwise. This is also counterclockwise. If you can see that, it's easy. You just have to think about how it's rotating it. 1, 2, trying to turn it this way. This one trying to turn it the other way, right? And this one the same. So, and then if you know where those are acting, you take the torque due to each one, you would go F2 times what? F2 times. Nobody's alive. What is the distance? I've labeled them. BC, very good. All distances are measured from B. F2 times BC plus F3 times BE should be equal to F4 times thank you, plus F1 times AB plus F5 times BD. And then after that, it's math. You have two equations. You can, of course, from this one, you're going to get one of the forces, then plug it back into the other equation, you will get it. All right. So that's the physics part of it. Here is the case where you can already see there's an object suspended by two strings, and you have to find the tension in the two strings. And to make it easier for me, I'm trying to say it's a symmetric arrangement. It need not be, you know what I mean? So in this one, let's assume that the arrangement is symmetric. What I mean is that these two angles, theta 1 and theta 2, are equal. But if you know how to work that out, you would know how to work the other one or anything. So here you have to draw the free body diagram and proceed. Tension 1, tension in the other, force down. These are the three forces that act. So that's 10 times, okay, or generally mg. And this would be T1, and this is T2. Just to give you a grip of what I'm doing. If those are the angles, you got to be a little careful. You know why? Watch this. What will this angle be? Is it theta 2? Is it theta 1?
No, it's half of theta 1.
It's neither. It's 90 minus theta 2. It's 90 minus theta 2.
Yeah.
You have to see that there. You see that little triangle here? The total angle is 180, correct? This is already 90. Come on. If that's 90 and this is theta 2, this should be 90 minus. So just be a little careful when you do that. So if that's 90 minus theta 2, I'm making trouble for myself. So let me call that theta 3, which is 90 minus theta 2, okay? And then same way, this would be what? 90 minus theta 1. So why did I have to do that? Because you have to resolve T1 and T2 into its components, don't you? Yeah, so resolve that into its components, and then you get the vertical and the horizontal, and you move. So that's the horizontal for T1, the vertical for T1, the horizontal for T2, the vertical for T2, little off, so you can see it. And then since these angles were labeled, was this the angle that was labeled? I don't know. You see, I should not have confused you. See, if we had taken this angle, let's go. Let's see if you get confused. That angle is theta 2, and that angle is theta 1. Hopefully, I've not confused you. So, according to my diagram, this is what? Theta 2. Therefore, this would be T1 cosine theta 2, and this would be T1 sine theta 2. So really, you did not need theta 3 and theta 4. I was just talking about different scenarios. Because I'm not trying to do a specific problem. You know what I'm trying to say? I'm trying to show you everything, which is a little dangerous, but anyway. So what about this one? T2, wouldn't this be theta 1? So cosine theta 1, and then the green one is T2 sine theta 1. Okay. So now you'll have to go and say, okay, net fx is equal to net fy is equal to 0. Both should be individually 0, right? Net forces along all the three should be 0. And there's no need of taking any torque here. Okay, so what do you get? What do you get when you do that? Don't you immediately see?
F force tension plus FA equals.
Is that right? The forces along the x must be equal to each other. They cancel out, and so too along the y. Well, along the y, you need to be T1 sine theta 2 plus T2 sine theta 1 should be equal to mg, or minus mg is equal to 0. Yeah. Because those two are acting up and this is acting down.
Instead of sine, can you just write 2 force tension sine theta?
Yeah, in this particular case, because it's symmetric, yeah, 2 times that is equal to mg. Yeah. Yes, that's why I'm writing the most general case, assuming that the angles are different and all that. Okay, so you being university physics students, you have to really understand the mechanism of how Carnot's engine works. How it works is heat is absorbed from the source, correct? QH is the heat absorbed from the source. Work is done by the working substance. Heat is rejected to the sink. The temperature of the source is TH. The temperature of the sink is TC. Those are the factors that you have, the variables that you have. What is the working substance, may I ask?
Air.
In Carnot's engine, it's an ideal gas. Air is the working substance in the real engines, like gasoline and diesel. Okay. So the formula for efficiency is basically work over QH, because efficiency is output over input. Output is the work and input is what it takes in, right? So then, because we know that work is QH minus QC, you could figure that into this, and so yeah, that's what work is. And then the other formula for efficiency is what? In terms of the temperatures, yeah, TH minus TC by TH. Those are the only two formulas in Carnot's engine. What is the efficiency of an ideal Carnot's engine? 100%. So in a problem, if I say, assume that the efficiency is only 90%, you've got to make amends for that. You've got to be careful. It's just a math thing.
You just have to do like 0.9 times E.
Yep. So you have to adjust for that and do accordingly. So this. One time I asked a Carnot's engine question this way, and I regret. I said a Carnot's engine works between ice point and steam point, find its efficiency. It's like a multiple choice question. A Carnot's engine works between ice point and steam point, find its efficiency. Half of the students did not know what ice point meant and steam point meant. Ice point is 0 degrees Celsius and steam point is 100 degrees Celsius.
Oh, sure.
But you have to have temperatures in Kelvin. So out of the half who remembered, at least 10% had the temperature in Celsius.
That'll probably be me.
So, I mean, it's your finals. You can't lose points like that. So be careful. Don't do that. Right? All right. Number 4. Essay number 4, last one, conservation of momentum, but in 2 dimensions. Now we'll talk about one dimension, and what is the principle of conservation of momentum. The total momentum before is equal to the total momentum after. It may be before firing, if it's a rifle and a bullet, or it may be before a collision. So generally you can say total momentum is conserved. But that is not true. It's only conserved, and that's my concern. If it's only conserved under a particular condition. What is that condition?
It's elastic.
No.
Close.
Total momentum is not conserved unless that condition is satisfied. And that's why students don't care. Students are like, total momentum is conserved. Okay. And then now I know how to get to you. Well, now I can't because I'm going to tell you.
No outside.
No external force acts on the system. So that could be. And I think there are like 6 or 7 conceptual questions out of the 20 multiple choice. There are 6 or 7 conceptual. Because otherwise you'll have a time problem. You know what I mean? If I give you 20 plus 4, 24 problems to solve, oh, that's tough. So there's roughly 20 to solve. Not 20, less, 18 I think. And 5 or 6 of them are conceptual, which is like you know it or not. That's it. If you understood the topic, you know it. You can still think, don't you think so? You can still think, read it, think, give it, whatever doesn't come to you automatically, keep it till the end and give it some more thought. Okay, so how do you write this? What is conservation of momentum? I mean, I would just say P is conserved or P is constant, isn't it? When external force is equal to 0. That is the principle of conservation of momentum. And when it comes to one-dimensional motion, I mean, it's easy if you have a mass colliding with another mass, and then after collision, they just move with different velocities. Okay, that's m1, v1, m2. Do you remember all this? No? So, what is the total momentum before?
What's
Yeah, so it'll be m1 v1 plus m2 v2 is equal to m1 v1 prime plus m2 v2 prime.
What's the collision when they stick together?
Or if they stick together, it's called a perfectly inelastic collision.
Take the mass together.
Yeah, and then solve. Now, unless it says it's an elastic collision, you cannot set the total kinetic energies to be equal. You see that? Again, let me say that. If I say in a problem, and I don't, so why should I even talk about it? If I say it's an elastic collision, then you know that total kinetic energies are equal before and after. But what about two-dimensional collision? How do you do that? Two-dimensional collision, so something is moving that way, something is moving that way, something is moving that way, and then after collision, you know, let's say they stick together and they move something like that. See? So now you will be given the mass of this first one, you have its velocity, you have the mass of the second one and its velocity. So now you know that you cannot simply take the products and add, can you? You can't, so what do you do? What do you do? You know,
resolve it?
well, you could do it that way. Let's go your way. Resolve it into its components, so that means you resolve the final into its components. What did I do? Would that be the horizontal and the vertical roughly? Correct? So you meant to say that the final momentum is resolved into its components. Isn't that what you meant? Yeah. Okay, because I'm taking it the way you said. So for sure you would know that this is the combined mass times some velocity, like common velocity, which is what we're looking for. We're looking for the common velocity. Okay? Come on. So how do you do that? Do you know the angle? I mean, how do you do that? If that's, how do you don't even know the angle at which that,
Yeah.
I just drew it.
Yeah, we don't.
You don't. So if you go my way, where you take the horizontal, the vertical, and you know that the resultant of these two should be the final, then that's easier. Okay, so then this is M1 V1. Oh,
This
oh,
question was on our, I think, exam 2.
I don't
It
know.
was like with an eagle or something.
Yeah, could be. M1 V1. And this is what? M2 V2. You know those numbers, don't you? I mean, you know those?
Yeah.
And they are at right angles, so can't you find the other vector? Yeah. A, B, C. So you can find AC is the sum of the square root of the sum of the squares. And then you can also find the theta, can't you? Yeah. We don't have the luxury of spending time on that math part. Then I wouldn't be able to run through this. But I'm giving you the most important. Those are the essays. So when you look at the SI units, it's not enough for you to know what the units are and what the quantities are. You should also know how they are defined. You need not memorize how they are defined, but look at on what basis they are defined. You know what I mean? Don't even cram. So how is the kilogram defined? So how do you know what's 1 kilogram? You need to have a standard somewhere, wouldn't you? So you can go back. No, that's not what I'm talking about. There needs to be a 1 kilogram standard that people could refer to, isn't it?
What is it?
That's what I want you to find. So how would you know what a meter is? And that standard should be an unchangeable standard, don't you think so?
Yes.
It should be something that can be replicated, that people can go to. Again, I don't want you to memorize what it is. Meter is measured in terms of a wavelength of light, right?
Oh, is that what it is?
Time is also measured in wavelength of a wavelength, in terms of wavelength. Mass, 1 kilogram is measured in terms of the actual mass of a platinum iridium cylinder kept in Paris. Yeah. So we need a standard. So you need to read that and get it. Yep, read that and get that. That will take you 15 minutes and you will be on your way to get 1 multiple choice question. So study how these have been measured. That's my last chance to make you look at that.
7 of them?
Have been defined. Yeah, 7 of them. And what are the 7? It's tough to write it, so I'll quickly say, or maybe I could. Kilogram is the unit of mass. Meter is the unit of length. Second is the unit of time. And then you have electric current in ampere. Electric current and candela is, of course, the unit of luminous intensity. Kelvin is the unit of temperature. Those are the basic 6. And then mole is the unit of quantity of substance. So whenever you talk about quantity, you talk in terms of moles. So those are the 7 basic SI units. Done. Significant figures. Just wanted to give you 1 multiple choice question and give you 4 points. Why else would I do it? What is the rule for significant figures?
Take like the least amount.
When you multiply and divide, it's different from when you add and subtract, is what I want you to remember.
Sig figs
So-
for multiplication and division, and then for adding and subtracting is the decimal point.
Correct. For addition and subtraction, you look at the smaller number of decimal places. But for multiplication and division, you look at the actual number of significant figures. You go with the lower significant figures. Now here is an example, or 2 maybe. That makes sense? Is that correct? 3 in this, 2 in this, so 2 in the product. 3 in this, 2 in this, 2 in the quotient. That's what it's called. Okay? All right, done. Projectiles. Didn't we talk about projectile motion a little bit? Let's check if we did. So if an object is thrown at 30 degrees with a velocity of 10 meters per second at 30 degrees to the horizontal, go ahead and find the time it takes to land back on the ground if it is thrown from the ground. Go ahead, find the time it takes to return to the ground. 10 meters per second. And the angle is 30 degrees. So wouldn't you first have to resolve?
From the ground to the ground?
Correct, from
Okay.
the ground to the ground. So
Well, are you saying horizontal displacement? I saw 10, so I thought that was the...
I was writing and I stopped. Yeah. So what is the horizontal component? 10 cosine 30. And this would be 10 sine 30. Okay. Delta y is what?
0.
That's the most important point. Would it be 0 all the time? No. What if it lands back on a table? Then it would be positive, the height of the table. If it lands into a hole, it would be negative, the depth of the hole. Okay, in this case, what would you use? What equation would you use?
Vertical component of the velocity?
And if I ask you to find time, you're going to use the king.
Yes.
You would use the king, and then 10 sine theta is going to be what, 5?
Yep, there you go.
Set it equal to 0, and then find the time. How do you find delta x?
Well, you know the acceleration in the x
Oh,
direction is
the-
0.
0. So
Horizontal.
the most important thing for you to remember is that the horizontal velocity never changes.
Yeah.
And if it's a constant, we talked about this the other day, then what you can do is multiply the 8, you get 8.67, I think, 10 times cosine 38.67. Correct? So 8.67 times whatever time you get. Okay. That's about projectiles. That's all about projectiles. I mean, it's impossible to teach you this, like, I would have taken 2 days or 1 day at least to teach you projectiles.
Could you do one where it lands at an angle, like top?
Oh.
We had one where.
Yeah, I know I asked you to do that. That would be one of the toughest questions. I did not ask you
Angle
on.
where it lands on.
I did not pick that one. Now, because Zach is talking about it, I'll change the exam.
No.
Now you'll have to pick that. All right, the next one is friction. And we talked about friction, didn't we? We did. While we were doing the essay, didn't we talk about friction? Yeah, told you F is mu k Fn and Fn is mg if it's on a horizontal surface. We also talked about if it's on an incline, it'll change, right? Fn won't be mg, so we did all that. So we need to move on. Which one is bigger, static friction or kinetic?
Static friction is bigger.
Okay. Keep that in mind. Motion of motion of objects. Oh, motion of an object in a vertical circle. Motion of an object in a vertical circle. So that is circular motion. What is the force that acts on any object that moves in a circle? It's called the centripetal force. And what is the direction of the centripetal force?
Towards the center.
Towards the center. If you remember that, this is going to become easy. So you have an object moving in a vertical circle at the lowest point, as shown. What are these two forces? What is this?
MG.
The weight of the object, mg, and this is the...
Centripetal force.
That's where you...
What
Look,
is the acceleration, dude?
see, you cannot show the centripetal force. I want you to remember this. You cannot... The centripetal force could be the gravitational force, it could be the tension, it could be the normal force. Centripetal force is a general term. You know what I'm trying to say? So you cannot show the centripetal force. You can only show what the centripetal force is actually in that situation. In this case, the centripetal force is the net force between the tension and its weight. Okay, keep listening. What direction is the tension in? Up? What direction is the weight in?
Down.
So when you take the net force, what are you going to do? Tension minus mg is the centripetal force, is what I'm trying to say. Now you got to get that. So tension minus, that's where students get confused. Students are like, tension is the, no. Tension minus, so let me write that and you can ask at the end. You will get a chance, because by then you might understand. Ft1 minus mg is mu squared by r. Is that making it clear? Well, I don't think if I'd drawn V1. You know that velocity is tangential at every point, don't you? So assuming counterclockwise rotation, isn't that the velocity there? Hey, that's not a force, okay? That arrow is just showing you the velocity. Is that making sense? If that is making sense, you go ahead and tell me a similar equation for the point at the top. Yeah, so think about, isn't it mg down, ft1,
Down.
and remember it's not ft, it's two different tensions. Would the tensions be the same at the bottom and the top? No, so that's why I have to call it ft1 and Fe2. And so do the velocities. The velocities will be different too.
Would it be slower on top? Right?
Definitely. We're going to talk about that too. Why would it be slower at the top? Because you talk about energy concepts.
That's right.
When your potential energy gets converted into kinetic energy when it comes down. See that? So surely the velocity at the top is smaller than the velocity at the bottom. That's why I brought this in, because that touches a lot of topics. So yes, what you were saying is correct. The centripetal force is the sum of the two. Do you actually have to cram that? No, because you understand. Look at the direction, both are down, so add them is equal to centripetal. With that, those two equations, you will be able to do anything that I ask you to do. That's it. And then think about, if I tell you, it's slowed down until when it gets to the top, the tension almost becomes zero. Could that happen? Yeah. If you slow it down, you could come to a point. So if I tell you that, then you put Ft2 as
0.
and then you have mg is equal to mv2 squared by r. The masses cancel out. You already got v2. And then you could use the energy concepts. You see, I drew that horizontal line. You know why? So if you assume that that's where you measure the height from,
Yeah.
what is the potential energy at that point?
0.
Okay. So what is the height at the top? 2 times the radius. 2 times the radius. Come on. And so according to the conservation of energy, the total energy should be the same at A and B. So potential energy at A plus the kinetic energy at A is equal to the same at B. That's it. With those two, you can absolutely do any problem. And a little bit of thinking. Next up, angular acceleration. So we are into rotation now. Did we talk about torque? No?
We did,
Yeah, for static equilibrium, just static. So what's the relation between torque and angular acceleration? I alpha. I alpha. And alpha is d omega by dt.
Yeah.
And what is I? Moment of inertia, rotational inertia, and then since you're making your formula sheet, I know you will have. This is the general formula for rotational inertia of a particle, so that's the general one. And then if you have a circular disk, which is a very important one, it's mr squared by 2. But doesn't it depend on the position of the axis? And all these, the axis is at the center, okay? And then do you remember the parallel axis theorem? Yeah, okay. Remember that, angular acceleration. Next up, torque. Now, torque is, there is a question on cross product. It's a multiple choice question because torque is the cross product of R and F. Do you remember how to take the cross product of IJK? Yeah, you do. So that is, you can knock it off. See, do not do F cross R. It's R cross F. So when you write it,
It's always minus plus, right?
yeah, you have to take the cross product. You know what I'm talking about, right? If R is like,
You still have to make
Can
it
you do
zero.
a quick example?
quick example? Oh goodness. Okay, I can.
It's just like taking a determinant of a matrix.
It is, kind of. So let me actually give 3i plus minus 4j plus 2k. That's vector, and that's the force vector is 2i plus 3j minus 5k, for example, and you're asked to find the torque. It's R cross F, writing again. So what you would do is you would go I, J, K. Isn't that what you do? And write the coefficients of R first in the first row, and then the coefficients of force, 2, 3, and minus 5. And just be a little careful. Okay, I'll slow down there so you know what I'm doing. Okay, when you look for I, you do not look in that row, in that column. You see the column of I, don't look at those numbers. Instead, go minus 4 times minus 5, minus 2 times 3. Is that clear? Yeah, the minus is not with the 2. You have to take the difference, that's what I mean. So it'll be minus 4 times minus 5 minus 2 times 3. Oh, I should have written it this way. Does that make more sense? And when you go for the J, I think you guys have been taught to take negative J, isn't it?
Yeah.
Negative J, and then don't look at the numbers below J. So wouldn't it be 3 times negative 5? See, I can't even write it that way. 3 times negative 5 minus, go ahead, 2 times? Yeah. And when you look for K, again it's plus K, and same thing, 3 times 3 was easier if I had just multiplied. Minus, yeah, or minus 4 times 2, doesn't matter. So which gives you, tell me quickly, this is 20 minus 6, 14i. And then this is what? Minus 15 and minus 4, minus 19. So but plus 19j. And here's 9 plus 6. 15? No, 9 plus 8. 17. Isn't that 17 plus 17k? Yeah? And decorate it by putting those caps. There you go. That is the torque. What's the relation between impulse and momentum?
Change in momentum over time.
Ha!
With time.
Change in momentum with time is force. So do you want to correct it?
Is it the average force?
Impulse is just change in momentum. J is just change in momentum. Or it could be average force multiplied by time. And the reason why I brought this is because students get confused. Now, force is, for you, force is dP by dt. So surely you understand that dP is force times dt, isn't it? That's what I've written here. Yeah. So impulse is the change in momentum. Please remember, impulse is not rate of change of momentum, okay? Impulse is change in momentum. It's on the exam.
So dP over dt is your average force?
Correct. It's on the exam. If an object is moving this way at 40 meters per second and it's hit straight back at 10 meters per second and the mass is 1 kilogram, find the change in momentum. A 1 kilogram object, something, I don't know, maybe a heavy ball, is moving at 40 meters per second, it's hit straight back at 10 meters per second, find the change in momentum. Or find the impulse. Impulse is the change in momentum, isn't it? Find it.
Velocity going backwards, negative.
Yeah, that's what you have to remember. And most do not. They will just go 1 times 40 minus 1 times 10, and you will get the change as 30, which is wrong. Because 1 times 40 minus 1 times 30. 10. And that minus came with the 10 actually, because the 10 is in the opposite direction. So that makes it 50, isn't it? Yeah, remember that. Just remember that. I'm telling you. There's a question that touches that. I just remembered, so I'm telling you. Because I don't want you to lose 4 points on that. If you forget that, you lost 4 points. So that's next up, work and power. What's work? Yeah, now for you work is the dot product of force and D, displacement, which is FD cosine theta. What is power?
Will work over change of time.
Work over time. Okay. So if I give you the force applied by a certain engine as 10,000 newtons, force applied by the engine of a car or whatever, and it's moving at 36 kilometers per hour, find the power of the engine. Now, if you're looking for direct substitution, oh, you're in the wrong place. So that's what I'm trying to show there. Force applied by the engine is 10,000 newtons, and it's moving at 36 kilometers per hour. First thing that the unit is wrong, right? You see, it has to be in meter per second, so that becomes 10 meters per second. But now the second thing is, how do you find power?
Can you put it over dt, force dt,
I,
put everything in microspectral time?
yeah, you tell me. You tell me the power.
What is it?
Yeah, go ahead, do it. Let me. Yeah, that's good. So power can be force multiplied by velocity. That's what I'm saying. Force multiplied by velocity, because velocity is distance by time, like you said, isn't it? So that's another way of. Okay. So, but you have to look at power when you lift an object. You know how to find the power, mgh by t. Because when you're lifting an object, aren't you giving it potential energy? So mgh by t. So
What's the units for power?
joules. Oh no, I'm joule per second.
Yeah.
Otherwise called, yeah. Yeah.
Okay.
Next up, pressure. And then what is the definition for pressure?
Force by area.
Yeah, there you have to be careful. Pressure is technically defined as normal force by area.
The gauge pressure.
It has to be the force has to be perpendicular to the surface, and there is a word for that. It's called thrust. Anybody heard about thrust? The word thrust means a perpendicular force. So technically, pressure is thrust by area. Although we say F, it has to be a perpendicular force. What's the unit?
Pascal.
Yeah, Newton per meter squared or Pascal. What is the pressure exerted by a liquid?
H rho g.
H rho g. Height of the liquid, density, and acceleration due to gravity. And then we know that the atmospheric pressure is 101,325 pascals. Never do it in ATM. It has to be in pascals or pascals. So what do you mean by absolute pressure?
Gauge pressure plus atmospheric pressure.
Okay, so that's why I wrote that absolute pressure there, because I wanted to remind you that it's gauge pressure plus the atmospheric pressure. What do you mean by gauge pressure? It's H rho g. So gauge pressure is what you mean by H rho g. Yep.
There was a question in the homework that asked for the gauge pressure, but we had to take into account like the absolute pressure, but it wanted the gauge pressure.
Oh yeah.
Yeah, then you'll have to subtract.
Why?
Why?
Because you can, it's connected to Bernoulli's principle. In Bernoulli's principle, you have to first calculate the absolute pressure. Only then can you go to gauge pressure. Let's talk about, I think Bernoulli's is coming. At that point, we'll go over that again, so we don't get confused here. I know exactly what you're talking about, okay? Even if it's not there, yeah, there it is. Bernoulli's principle. So what is Bernoulli's principle mathematically? I mean,
Energy at
Fi-
the start is energy at the end.
correct. But Bernoulli's principle is simply a conservation of energy. And there are three types of energy. What are the three types of energy? And pressure. Yeah, pressure can, see, these are more, it's, you just did this, so, you know. Now, so what is the formula for potential energy? That?
MGH.
Kinetic energy is that? And what? Yeah, good. Where dV is the volume, isn't it? You're talking about a small volume. Okay. So That would be easier for you to remember, is what I'm trying to say. But that's not how you will find it in your formula sheet, and I'm going to tell you why. So this is going to be constant. In your formula sheet, you see mass in both of them. In two terms, don't you see mass?
Yeah.
So if you divide throughout by mass, you could get rid of the mass. And so here you have volume by mass. You see that? What's that?
Density.
No, 1 by density.
Oh,
So P by rho. Plus this becomes GH. This becomes V squared by 2. That's how you would see it on your formula sheet. Yep. So that's written per unit mass. It could also be written per unit volume, but I need not confuse you. So that is Bernoulli's principle. And here is where your question that you asked me is going to be explained. So if you're talking about two parts, one having a bigger cross-sectional area, the other smaller, and of course you have to combine this with, and if it's a horizontal pipe, you don't have to consider the
height.
Yeah, because it's the same on both sides, so now it becomes really easy. And therefore, I'm going to take a little bit more time on this because I think this is almost the end. So P1 by rho plus V1 squared by 2 is equal to P2 by rho plus V2 squared by 2. But I'm calling this 1 and this 2, okay? And again, you have area of cross sections A1 and A2 here. Do you also know the relation?
It would be 1.
Yeah, is equal to A2, which means where will it be flowing faster?
At 1.
At 1. So where is the pressure smaller?
1.
Okay. Where is it flowing faster?
1.
1. That's for sure. Did everybody get why it's flowing faster at 1? They won't because of this. Where the area is smaller, yeah. But now to go to where is the pressure bigger or smaller, you have to use Bernoulli's principle. So take a look at it and then answer. Take a look at Bernoulli's principle. We already found that V1 is greater than V2, didn't we? Okay. If V1 is greater than V2,
Pressure.
P1 is surely less than P2. So where the velocity is higher, the pressure is, that is Bernoulli's principle. Where the velocity is higher, the pressure is lower. Did that make sense? And then, what pressure is this? Is this the absolute pressure or the gauge pressure?
Gauge.
No, it's the absolute pressure. So write that down there. In Bernoulli's principle, whatever you see is the absolute pressure. So if you are asked to find the gauge pressure, there's no other way than to first find the absolute and then subtract the atmospheric pressure. So that's why you had difficulties on the Weber sign. Because you probably are thinking that this is either the gauge pressure. No, it is not. Did you understand what I'm trying to say? So if P1 is given, or if you have to get P1, it should be the absolute pressure. And what you get will be the absolute pressure at 2. Okay, let me try to say it another way. If P1 is the gauge pressure at 1, P2 will not be the gauge pressure at 2. Let me try another one. If P1 is the absolute pressure at 1, then P2 is the absolute pressure at 2. Now did it make sense? Because in that math relation, the addition of 325 will not carry over. So that's what I'm saying. So please remember that is the absolute pressure. You cannot work out with the gauge pressure. That's all. I did my part.
So is H rho G, is that,
That's the gauge pressure.
okay.
So that would be, let me show you something like to connect with that. Suppose you had a tube here. Oh, I need to make an adjustment here. Okay, so if you, let's say you had a, but how would that? Okay, I can go. So if you have two vertical tubes here, so as the liquid flows, it will rise up in those vertical tubes, right? And both are open to the atmosphere. I mean, there's enough height so the liquid doesn't spray out. Are you with me? So when the liquid rises, where will it rise up more? Where is the pressure greater?
Pressure is
P2.
greater.
So surely it'll rise up more here, and here may be something till here. So if H1 is the height here, H2 is the height here, I'm trying to tell you that the pressure difference between these two would be P2 minus P1, isn't it? Which is greater, P2 or P1? That should be H2 minus H1 rho G is what I'm trying to say.
Is that absolute?
Yeah, the difference in the absolute pressures would be the gauge pressure. So that causes confusion always for students. That's why I brought that in. Bernoulli's principle, I like it. Did we talk about the lift of an airplane when I told you Bernoulli's principle? I should have. I mean, that's absolutely. Let me see if there's something else. Oh, there is. Oscillations, last part. Is it last? I don't know. Springs, what's the formula? Time period, we just did that. Time period, 2 pi. Huh? K over M or M over K? M over K. Omega is root K over M. Oscillations, springs. So what's K? It's the spring constant.
Yeah.
If it's a light spring, you need not consider the mass of the spring, but if it's a heavy spring, you have to take 1/3 of the mass of the spring and add it to the mass attached. So remember that, and you will have a multiple choice question.
I don't believe you.
What's considered a heavy spring?
Okay,
Oh, yeah, what's the-
that's a genuine question. If you have a 100-gram mass attached and the spring has a total mass of like 5 grams, that's not a heavy spring, because that's 5% of the.
So
But
it's proportional.
but on that 5-gram mass, if you attach a 1 gram, now that's a heavy spring. How many understood?
Yeah.
So it's not the mass of the spring that makes it heavy or light.
What percentage of this was
Exactly. So that's why when you do that lab, I have so many dreams it doesn't happen. I actually want students to do labs without me giving the procedure. There's only one time I taught an honors class, and that's the end, and people are so angry with me. Because in the honors class, I thought I should do justice, right? So I said, I made some changes. One change was I took it to a little higher rigor in calculus. Number 2, I made them do labs 2 days. First day, they would figure out what to do. Second day, they would do it. And guess what? I always had to go back and tell them what to do. On day 1, I wanted them to brainstorm. I would say, find the spring constant of a spring. And I would give them the spring constant. The spring. That's it. And I would say, ask for anything else you would need. You know what I mean? So they had to figure out, you have to have a motion sensor. Why? Isn't it thinking now? It's not easy. That means you have to find that time period, which is easy, to work backwards. They just sat, chit-chatted. And then I said, that's the end of honors. So 1 semester and I was done. Why do you call it honors if you can't step it up? Okay, linear expansion, what's the formula?
Change in-
The change in L equals L naught.
Alpha.
Alpha delta T.
Okay, L naught is the original length. But if I ask you for the new length, of course you have to add, yeah.
Add L naught plus.
And if it's a change in area, you know what to do?
2 alpha.
2 alpha. If it's change in volume, it's 3 alpha and all that. So you're experts now. I'm looking at like 90% and above on this exam. I mean it. What is the ideal gas equation? No, that's what you get from the ideal. PV is equal to RT, right? Yeah, but what's N? Number of moles, and this is 8.314. Universal gas constant, joule per mole Kelvin. T is in Kelvin. Okay, pressure is, P is pressure, I mean in pascals. Volume in meter cube. This must be an easy thing for you to do. Only thing you have to remember is if I talk of oxygen, it's molecular weight. Yeah, it is diatomic, so its molecular weight in kilograms is 0.032, just as an example. So 0.032 kilograms makes 1 mole, right? Oh, I put MOLE. Okay, 1 mole. That's something else. All right. And then from that, the last, can you get all the gas equations? Just from the ideal gas equation?
Adiabatic and all that, isotopic?
No. Just the gas equations.
Oh, yeah.
Okay, let me, just tell me how you would.
V1 is equal to P2, V2.
Okay, how would you get that? If the temperature is constant, then all of the terms on the right side became constant. Do you see that? N and R are already constants. So that's when you get P1 V1 is equal to P2 V2. That is Boyle's law. Best example, an a bubble rises from the bottom of a lake and comes up. What happens to its volume?
The
Increases.
pressure decreases.
Volume increases, right? And Charles' law, V1 by T1 is equal to V2 by. One time I had this, I may have told you, this problem of calculating the tire pressure at 2 different temperatures. And I had given the temperature in Celsius. And at least 10 students that semester kept it in Celsius. So it would give you horrible results, because if this is like 23 degrees Celsius and the pressure is, let's say, 100 pascals, and I would ask you what's the pressure at 46, if you don't take care, you're going to say 200, right? Because
Yeah.
Shame. So just temperature increasing by 23 degrees Celsius, double the
Doubles
pressure.
the pressure.
So that should have, told them, but they didn't. Those are the students who don't understand, not you. And I can